Okay, hi everyone. I'm Dr. Thomas. Today I would like to share some water treatment basic knowledge uh, related to sustainability and efficiency with the topic of unleash your total water treatment knowledge in enhancing sustainability and efficiency. Next. Next. Okay. Before we start, let me recall what about the total water management, total water treatment. Yeah. So generally, a lot of people, when talking about the water treatment, firstly, they will relate to the wastewater treatment. But in fact, it's not totally true because in water treatment, they have some other type of water treatment. Example, raw water treatment, boiler water treatment, cooling water treatment, and wastewater treatment. So in this sharing, I will talk briefly about what is about for this water treatment for each system. Yeah, next. So for the raw water treatment, basically, the water that we drink, we use for daily or for industrial application, we need to treat it before we can use for the various type of application. So normally the water, they are the source for the raw water maybe from a river, cheap well. So the water contains a lot of impurities and pollutants. So we need to remove it before we can use it. So basically they will use a lot of treatment process. The common process that we use in the market is by using chemicals, coagulation and flocculation. So to separate the suspended solid to get the clean water before we can use for our daily application, especially for industrial application. Yeah. So this is the after treatment. The water will be very clear and can be used. Next. So for the boiler water, basically the boiler is a machine that produces steam for the industry use. So after this raw water be treated, we can get the clear water. But in fact, there's a lot of impurities such as total suspended solids with very fine particles that we cannot see by our naked eye. And also some dissolved solid, TDS, like magnesium, calcium, chloride, iron, and silica. All these dissolve in water. The parameters we cannot see by any eye, but we can measure it by all the equipment to test, and also the content of dissolved gas like oxygen, carbon dioxide. So these all impurities will affect our boiler water treatment operation, yeah, such as when deposition, scaling, so mainly from hardness. So when treated water, even the water very clear, we cannot see it. But if we never treat it well, so the hardness, especially calcium, magnesium, it will form a scale. We call it deposition and scale in the boiler. So the consequences, it will reduce the heat transfer efficiency and affect our whole operation. And beside that, when all dissolved gas in the water, we never treat it properly, so it will cause a pitting at our boiler tube. This is the example of the pitting corrosion. And the finals, when the chemicals we never treat it well, so it will form forming and carry over as well. That's why boiler water treatment is very important. And from there, we need to know the fundamental before we can use it for our application. Next. So beside the boiler water treatment, there's another water treatment we call cooling water treatment. It's a reverse process. The boiler is produce steam, but cooling is to cooling the hot water for process and maybe for some cooling system. So the same thing. So the cooling water consists of a lot of impurity like suspended solid, TDS, and dissolved gas. So all these impurity also might cause a few problems in the water, our cooling machine. For example, deposition and scaling also form the calcium magnesium. And the corrosion, same thing. If we never treat it properly, it will form a corrosion in our condenser, especially in condenser. Yeah. And another problem that will not happen in boiler, but it will happen in cooling water is nitrogen fouling. So generally, the water consists of a lot of these nutrients and also exposed to sunlight. So when the system running, so the microbiology, they will form. If we never treat properly by using biocide or to control it, so if the consequences, all the microbiology of algae will grow and block all this condenser, and if it is the consequences, it will cause the heat transfer efficiency drop. So this is the main problem. If we never do the proper cooling water in the market, a lot of people will do a treatment, but how well they are doing? talking about efficiency, because in cooling water, talking about the mass transfer, the heat transfer. So if let's say we never treat properly, definitely the heat transfer will going down, and the process of the heat cooling part will be affected. So next. So another water treatment is very important is the wastewater treatment. In our Malaysia context, there are two main wastewater uh, category. One is called sewage treatment and one is called industrial effluent. So in here, if the wastewater never treated properly according to the regulation stated in Environmental Quality Act 1974, so all the water discharged to the river eventually it will cause a lot of pollution and affect the whole aqua life in our lives, daily life. That's why the wastewater is very, very important. This is the main reason that when talking about water treatment, a lot of people dialect or think about wastewater treatment. So in fact, they have a wastewater treatment is part of the water treatment total measurement. Yeah. So next. So we're talking about total treatment, then we need to think about sustainability. What is sustainability? Nowadays, a lot of people talking about sustainability. How is sustainability work? In fact, the objective of sustainability is to create a harmonious relationship between a human being like us and an environment to ensuring that our today action do not jeopardize well-being and opportunity of our next future. For example, the forest nowadays, if we always to use up all the forest, all the wood for our today activity, eventually the forest will be reduces, so it will affect our future generation. That's why sustainability is very important. In the sustainability context, there are three things that we can do it. One is energy management, waste management, and the water management. So this part we will talk more detail in our ESG part. But when come back to sustainability, how we can manage all these energy, water, and the water and these waste to achieve our sustainability goal. So next. So when you're talking about sustainability, then we need to talk about carbon footprint. So what is carbon footprint actually? So the carbon footprint is to represent the total amount of green gases, or we call GHG, resulting for everyday economy and the human being activity. For example, we drive our car, we use the vehicle every day. So the fuel that we're using our vehicles, it releases a lot of the carbon dioxide. So this is the main problem. So this is the main problem that will affect will increase the GHG to atmosphere. That's why we need to understand what is the carbon footprint definition, and from there we need to come out some action how to reduce it to achieve our sustainability goal. So next. So basically, according to the greenhouse gas protocol, GHG protocol, so we have split three categories for this emission for the carbon footprint or carbon dioxide emission. Scope 1 is direct GHG straight to the sources. For example, we use a vehicle car or we use the boiler to release all this gas to the atmosphere. So for our carbon dioxide, this is scope 1. For scope 2, so it's indirect gas emission that arise from our generation or purchase of electricity, heating, and cooling steam. So this is all our purchase it. Then for calculation, we need to calculate what is the carbon dioxide emission. And for third one is the indirect GHG gas emission that originated from the activity related from our supply chain. For example, we purchase the raw material, the water, the goods that were used for as raw material and also produced as a product. So this is all under scope 3. So this is the thing that we need to understand about the GHG protocol. Yeah. Next. So once we understand the GHG protocol and also carbon footprint, then we need to come to how to manage our carbon emission. So basically, they have 4 levels. The first level, we try to avoid it or cut the carbon source, eliminate whatever activity or whatever material that it will cause a high emission of carbon dioxide. So this is the first thing. So we need to understand our material, our activity, and from there we can do the first step of the carbon management. For second, we need to reduce it or optimize the operation process to reduce the usage of energy or utility. So this part, for as a chemical engineer, we need to understand our process and we need to optimize all the heat can use back as in heat integration. So whatever the heat that produced from the process, then we can integrate to use as another heating of resources, or from the cooling water side, we how to reduce our water consumption to make the process more efficiency, and eventually it will help to reduce this carbon dioxide emission. And the third, so is replacement. So replace with a low carbon or environmental friendly or green tech technology. For example, nowadays a lot of people talking about the scheduled waste, the chemicals, hazardous. So now we try to replace some hazardous chemicals with green chemicals. That can profit or they can bring profit beneficial to our environment. So this is for replacement. And from the process, we can identify which part we can use for replacement. This is for the team, we need to understand it. And last, when the level 1, 2, 3, we cannot do it again. So the last, we need to offset. The offset, normally we are neutral emission by investing the carbon induction or carbon capture system. For example, we do this carbon credit. So we need to purchase some carbon credit from other resources to offset the carbon emission that released from our process. Or we can use the renewable energy from our plant. For example, we install control panels. So control panels, where we calculate what is the energy produced, then from there we can register for the REC, renewable energy credits certificate, to offset our this power consumption, and eventually will cut down our carbon dioxide emission. So this is for our carbon management for sustainability. Next. So that's all for this total water treatment, how we can optimize our process to achieve this sustainability and increase the efficiency of the total process. That's all. Thank you for your attention.